Hi students, in this video I'll be going through some concepts regarding logarithms, as a form of a recap. So the first concept that I would like to talk about would be how to convert exponential form of an equation to the logarithmic form. So for example, if we have an exponential equation, y equals to a to the power of x. So we need to recognize that this a over here is actually the base. And then this x over here is what we know as the index or the power. All right. So when you convert it to a logarithmic form, how will it look like? So the way to convert is that once you convert this x, right, this power is going to be on one side by itself. So this will be the power. And then what will happen is that the base will still remain as the base. But now it's not the base of an exponential function, but the base of the logarithmic function. So you have log base a, and then the y goes over here. Right, so you need to be able to convert between exponential form and logarithmic form, or conversely the other way around, logarithmic form to exponential form. So this is one thing that you will need to know. So the next thing that I would like to talk about would be to talk about two special properties of logarithms. So the first special property would be if you have log base a1, you will get 0. So let's verify this by converting it to exponential form. So if we convert it to exponential form, remember the a is now the base, and then this 0 here is the index or the power, right? So we will have 1 equals to base a to the power of 0. We know that if you power anything to 0, it's going to become 1. So this verifies that special property 1 is correct. So special property 2 goes like this: log base a will be equals to 1. So same thing, I'm going to convert it to exponential form. So if you convert it to exponential form, you have a. Over here you have the base, and over here you have the index, right? So you have a to the power of 1. So we know that if you take any number and you power it to 1, you will get back the same number. So we know this to be correct as well. So just to summarize the two special properties, log base a1 is 0, log base a is 1. So these are two things that we will make use of it later. Next one, let's take a look at the laws of logarithm. So the first one is known as the product law. So if you have log base ax, plus log base ay, if you combine it to a single logarithm, it will become log base axy. So one thing to note, to apply the laws of logarithm, the base will have to be the same. So in this case, both base a, and then once you go onto the right side, once you convert it, it's still base a. Alright. So this is the product law of logarithm. So why they call it the product law is because over here you have x times y. That's why it's the product law. So the next thing would be the quotient law. Log base ax minus log base ay. So once you combine them into a single logarithm, you get log base a x over y. And this is why they call it the quotient, because now once you combine, you have x divided by y. So the last law that we'll talk about is the power law. So if you have log base a x to the power of r, the power law states that we can bring the r in front, the power in front, and then we will have this. So this would be the power law. Finally, before we look at the questions, let us look at this important thing called the change of base formula. So the change of base formula actually allows us to change the base of a logarithm to any other base that we want. So let's say we want to change it to base c, right? So all you need to do is write log base c over log base c. Then this b over here will just go on top, and then this a will go below. So you have log base cb over log base ca. Okay, so this is actually very useful because it allows us to change the base of a logarithm to any base that we want. Okay, let's apply what we have just recap to two O-level questions. Okay, so the first one is from the 2018 paper, paper 1, question 6. Okay, so this is a show question. So we are asked to show log base 3x plus log base 9x equals to 2 log x over 2 log 3. Okay, at this point, I would just like to go back and just recap two things. Okay, so sometimes you will see LG, right? Okay, so LG, let's say LGX. Okay, LG means logarithm to the base 10, right? And then the other logarithm that you will see is the natural logarithm. Okay, it's ln ln. Okay, so ln would be log base e x, right? So these are two things that you need to take note of. Okay, because straight away over here you can see there's two LGs over there. Okay, so we have to show log base 3x plus log base 9x is 2 log x over 2 log 3. Okay, so we should start off often by from the left side, and then we move to the right side, and then we try to show this. Okay, so we have log base 3x plus log base 9x. Okay, over here. Okay, so if you look at this kind of show question, I remember that every single step that you take has to have a purpose. Okay, so every single step you take has to have a purpose. Okay, so if you look at the right side, is base 10. Okay, so if I were you, I would try to convert everything to base 10. Okay, so let's apply the change of base, okay, to convert both base 3 and base 9 logarithm to base 10. Okay, so over here, I will have log LG, I want to convert to base 10. So the x goes on top, the 3 goes below. So very simply, we have this. Okay, so if we do the same thing over here, we will have log, okay, x over log x over log 9. Okay, so now the next thing that we need to think about, now we have two fractions, right? And we are adding them together. But the final result, we want a single fraction. So in order to do that, remember to combine two fractions, you need them to have the same denominators. So let's try to convert both denominators to the same. One is log 3, one is log 9. So I guess it's always easier to convert the bigger number to the smaller number. Okay, so over here, okay, what you should recognize for logarithm is you can always do this. Okay, 9, we can always change it to 3 squared. Okay, then we can use you should recognize that now we can use the power law, right? Okay, we can use the power law to bring the 2 in front. Okay, so you have 2 log 3. So now both base have log 3 already. Okay, so if both base have log 3, okay, I'll continue over here. But on this right side, is 2 log 3. So in order to combine two fractions, I need both of them to be 2 log 3. So I will put a 2 here and a 2 here. Okay, so if both are 2 log 3, you have 2 log x plus log x, you will have 3 log x. And we have shown it already. Okay, we have gotten from the left hand side, okay, to the right hand side. Okay, so we show. Right? Okay, next part is we're asked hence. Okay, so whenever you see hence means you need to make use of answer from your first part. So for the first part, we have already proven that this one, okay, can be expressed in this form, right? Okay, so to start off, we will replace the log base 3x plus log base 9x with 3 log x over 2 log 3 equals to 4, right? Okay, then if you look at this, what is there to be done now? Okay, so the only thing that comes to mind would be to cross multiply this one up, right? Okay, so 4 times 2 log 3, you will have 8 log 3. Okay, then since we are solving for x, so we want to slowly isolate x on the left side. So over here, we have the 3 here. I'll divide the 3 over, so you have 8 over 3 log 3. Okay, so one thing to know about solving a logarithmic equation is this. We try to always do this. Okay, let's say we have log ax, right, equals to log ay. Then we can conclude that x equals to y. Okay, so over here we have log x, over there we have log 3, but then there's a 8/3 in front. So what do you think we can do? Yes, okay, we can actually use the power law, right? Okay, we can use the power law to bring this 8/3 on top. So if log x equals to log 3 to the power 8/3, then it just goes to show that, or goes to mean that x is equals to 3 to the power 8/3. Okay, then all you need to do is use your calculator to work this out and give your answer to 368. Okay, so the answer will be 18.7. Okay. Okay, so let's look at one more question. So this is a question from 2017 paper 2 question 5. Okay, so same thing, there's plenty of chances to apply the laws of logarithm here. So over here on the left side, we have this. On the right side, we have this. So this is a solving question, not a show question. Okay, so same thing, we want to come to this conclusion. Okay, then x equals to y. Okay, so in order to do that, we need to have only one logarithm on the left side and one logarithm on the right side. So how can we combine the left side together? Okay, minus, so we will use the quotient law, right? Okay, so we will have this. So if we combine, we will have this. Okay, how do we combine the right side together? This is just a 1. Okay, so we need to recognize that we can actually do this. Because log AA is 1, right? Okay, so in this case, if I want to combine these two, we need both to be log base 5. So can I write 1 as log base 5, 5? Okay, so nothing wrong with that, right? Okay, then once we have this, both base 5, we can then combine it together. Okay, so it will become log base 5. So it's a plus now, so it will be product law 5 times 1/7, you have 5/7 over here. Okay, so on the left side we have this. Okay, so we have already arrived at this stage already. Okay, log base ax equals to log base ay, therefore x equals to y. So since both are base 5, so we can conclude that x minus 1 equals to 5/7. Okay, then we just cross multiply. Okay, so questions like this not difficult at all. Okay, so be confident, alright? Okay, so let's bring over. So 7x minus 5x will be equals to 5 plus 7. So 2x equals to 12. So x will be equals to 6. Right? Okay, so if you substitute the x equal to 6 back here, then you know there is a valid answer because you can log 5 and you can log 7. Okay. Okay, so this will be the solution for this question. Okay, let's look at one last question. It's a 5-mark question. Okay, but you realize that it's not difficult also. Okay, so over here you have log base y100 equals to log base 10y. Okay, so one thing I will be thinking now is maybe we can try to convert everything to the same base. Okay, since the right side is already so simple, right? Log base 10y. Okay, I will attempt to convert the left side instead. Okay, so let's use the change of base again. So the change of base that we need to know is we're going to use it very often. So if we do this, we will get this, right? Okay, then straight away you see there are common things there's a log y that appears on the denominator of the left side. And then the right side is the log 100. Okay, so is there any way that we can simplify the numerator, the log 100? Okay, so we should recognize that log 100. Okay, remember LG means base 10, right? Okay, so we can convert it to 10 squared. Okay, then over here, okay, let's leave this here first. Okay, let's not disturb this. Okay, so over here we can then apply the power law. Okay, bring the 2 in front. Okay, then what will we get from log 10? Okay, so LG 10, remember LG means base 10, right? So log base 10 is going to give us 1. So over here, we'll just simplify the question to just like this. Okay, so the question is now much simpler already from having base y and 100 becomes a 2 over log y. Okay, so all we need to do now is to bring the log y to the other side. So remember, these are log y times log y by cross multiply, right? It's going to become log y squared. Okay, and this one, can we bring the power in front for log y squared? Okay. Okay, so we can only bring the power in front if the square belongs to the y only. So what I mean is this, okay? Then we can use the power law, bring the power in front. Okay, so this is equal. But if we have bracket here, we are squaring the whole of log y, then it's not equal anymore, right? Okay, so basically what we can do to solve this is, okay, let's solve it over here. 2, right? Okay, we will square root both sides. So if we square root both sides, we will have square root 2 or log y equals to negative square root 2. Okay, then remember log is base 10. Okay, so this is the base and this is the power, okay, in the exponential in the logarithmic form. So to solve, we will convert it to exponential form. Okay, so it's very important to know how to convert between exponential form and logarithmic form and vice versa. Okay, because often it's the last step to solving the expression. Okay, so 10 to the power of square root 2, okay, it's going to give us 25.95. Okay, they want the answer to 2 sig fig, if you recall over here. Okay, so to 2 sig fig will just be 26. Okay, 2 sig fig. Okay, then same thing for here, log base 10y equals to negative root 2. Okay, there is a solution for this. Log can have negative answer. Okay. Okay, so you'll get this. Okay, then if you convert it here, okay, what I mean just now, log can have negative answer. That means when you log something, it's possible to get negative. Okay, so don't go and reject it. Okay, so 0.0385. So you will have 0.039. Okay, to 266. Right? Okay, so I hope this video has been useful to help you to recap some of the main essential concepts in logarithm. So after this, you will need to go and practice some questions on your own so that you will become confident in applying the concepts. All right.